All right, so if we're naming these compounds, we're going to have to know whether at least so far in our naming rules, what we've learned so far about naming ionic compounds, we need to know whether the cation has more than one oxidation number. If it doesn't have more than one oxidation number, we simply name it the way it appears in the periodic table. If it has more than one oxidation number, that oxidation number for that compound is written as a Roman numeral following that name. So if we look on the periodic table with oxidation numbers for calcium, you'll see that calcium only has one oxidation number, so we don't need a Roman numeral. There's no reason to call it calcium 2 when it can only be calcium 2. Okay, so what we want to do is to write simply calcium, and the word at the end for the element that comes at the end is simply named with an ID ending, fluoride. Okay? Now we've already learned to name covalent compounds. We've already learned to name some simple organic compounds. The kinds that we learned to name are called hydrocarbons. And now we're moving into ionic compounds. So now we have aluminum and iodine. And aluminum, again, only has one oxidation number, 3+. So all we have to call it is aluminum iodide. We change iodine to iodide. Okay? Alright, so now we go to this next one. Now what we have is manganese, and manganese has a lot of oxidation numbers. It has 5 different oxidation numbers. Okay? So we have to figure out which one this one's going to be. So we're putting it together with a sulfur, and if manganese only has positive oxidation numbers, our compound has to be neutral. So we need to find a negative oxidation number for sulfur, and the only negative oxidation number that sulfur has is 2 negative. Okay? So if this is 2 negative, and we have 2 of them, okay, this 2 here means I have 2 sulfurs, then I need a charge on the manganese because I only have 1 manganese. And your charge on the manganese is that will balance out or cancel out the 2 negatives here. And the charge that will balance out or cancel out the 2 negatives is a 4+. Does that make sense to everybody? Anybody have any questions about how I got that? We're simply undoing the same process we used when we were writing these compounds or balancing these compounds back in the last. We actually started on that process 2 units ago. We spent a lot of time on it in the last unit. Okay, so now when we name this, since manganese has more than one oxidation number, we have to name this manganese 4, and that's a IV, manganese 4 sulfide. Okay, when we're naming covalent compounds, non-organic covalent compounds, we would have put a di in front of sulfide. But this is not a covalent compound, so we don't use that system. We use this system when we're naming ionic compounds. So you first have to identify whether it's an ionic compound or a covalent compound. And almost always, when we put metals and nonmetals, it's going to be ionic. Almost always, when you put metals with nonmetals, it's going to be ionic. Okay? There are some exceptions, but for this class, you won't really have to worry about it given the rules I will give to you. Okay? All right. Now we're going to put together lead and selenium. Okay? Well, lead has 2 different oxidation numbers. It has a 4+ and a 2+ charge. So we need to know what the charge is on the selenium. Put our lead down here and the selenium here. We've got 1 of each. So what charge do we have on the selenium? Selenium has the only negative charge it has. Lead has only positive charges. So the selenium has to be some kind of negative charge in order to balance it out. So since we have the negative charge we have on selenium is 2 negative, and we have 1 of each, the charge on the lead must be, y'all stop worrying about the other things and pay attention to this. If the Selenium must be 2 negative. What does the lead have to be if I only have one of each? 2 positive, thank you. Okay, and so we're going to name this lead 2, Roman numeral 2, selenide. Okay? Alright, here's our grading system. I'm going to give you 1 point for the word calcium here, 1 point for the prefix CLOR, and 1 point for the suffix IDE. The same here, 1 point for the word aluminum, 1 point for the IOD suffix for iodine, and 1 point for the IDE suffix. Okay. Down here, we're going to have a point for manganese, a point for the correct Roman numeral, okay, a point for putting that Roman numeral in parentheses, and a point for the SULF suffix, and a point for the prefix sulf and the IDE suffix, okay? So that one's worth 5 points, okay? So manganese, parentheses, Roman numeral. That's where those 3 points come from. Sulf and iodine is where those 2 points come from. Same with this one. 1 point for lead, 1 point for the parentheses, 1 point for the correct Roman numeral, 1 point for the SELEN, actually root word, and the 1 point for the IDE suffix, okay? So 5, 10, and then we got 16, so we have a total of 16 points just for this first section. All right, then we're going to go on to the next section here in a minute. So, let's see, where was I? There we go. Okay, so we want to write 4 formulas for 4 names that I have here. We've got strontium sulfide, okay. Alright, so strontium sulfide. Well, strontium is Sr. Sulfide comes from sulfur, so that's simply S. Now look up the charges. Strontium only has 1 oxidation number, that's a 2+. Sulfur only has 1 negative oxidation number, and it has to be negative because otherwise we won't balance out the charges. And the only negative charge available to us for sulfur is 2 negative. So I hope you can see you only need 1 of each of these, and the formula is SRS. Capital S, small r, capital S. Okay, if they don't have a clearly capital S and small r, followed by capital S, it's not right. Okay, you can't write SRS or SRS and call that the correct formula. It simply isn't. Okay, you have to clearly show the capital and lowercase letters. Okay, those are not correct. All right, this is the correct formula, and we're going to give this one a point for the correct formula for our symbol for strontium, a point for the correct formula for sulfur, and 1 point for balancing it properly. Okay. This part right here. I didn't ask you to show the work, I only asked you to balance it. Okay? I'd rather you show the work, but I didn't ask for that. Alright? If you show me the work and you get your answer wrong, you might, if I'm grading a quiz or a test, you might get partial credit, because if I see some error that I think is not, maybe you don't deserve to lose all 3 points. You only deserve to lose 1 point. Okay, so it's always better to show me the work. Okay, but I don't want to count it against somebody that didn't show me the work when I didn't ask for it this time. Okay. All right. So the next one we're going to look for is rhodium 3 chloride. So rhodium has 3 different oxidation numbers. 4 and 3 and 2. And we need to know which one this one's going to be. Well, it says it's rhodium 3. So we know it's 3 plus. Chlorine, from which we get chloride, has only one negative number, one negative oxidation number, Cl negative. So in order to balance this compound, I'm going to need 3 negative charges to balance this 3 positive charges. So I need 3 of these particles. And when we write the formula, it becomes RHCl subscript 3. Okay? So the coefficient here, when we're adding these 2 different ions together, when you bond them together, the coefficient becomes a subscript. Okay? All right, number 3 is potassium phosphide. Oh, I'm sorry, I haven't given that to you yet, have I? Yeah, let's go back and put a point scheme on this one. I think we can do the same thing here. 1 point for the rhodium symbol, 1 point for the correct chlorine symbol, and 1 point for balancing it properly, which means there's no subscript here and a 3 here. Yep. All right. So potassium is K. P is phosphorus. You've got to make sure you're using the right element here. Okay. Potassium only has 1 oxidation number. That's a 1 plus, which we only write as a plus. There's no reason to write 1 plus. There's only 1 of them. We're going to find phosphorus, from which we get the phosphide. And we see the only negative number that phosphorus has is 3 negative. Okay. I have a particle that has a 3 negative charge, and I have a particle that has a 1 plus charge. And the only way to get a compound that has a balanced set of charges is if I have 3 of these positive charged particles to balance out this 3 negative particle. And so the formula becomes K3P. Okay, so 1 point for the potassium, 1 point for the phosphorus, and 1 point for balancing it properly. And the last one is chromium 6 fluoride. Please pay attention to how fluoride is spelled. Please don't write fluoride, okay? It is fluoride. So chromium 6, that means the chromium has a 6 plus charge. You really don't even have to look it up. Okay, if you know that Roman numeral is a 6, you just know it's a 6 plus. We do have to look up or know what the fluorine charge is, and this is, Krista was asking about this yesterday. If you look carefully, if you're putting together ionic compounds, particularly binary ionic compounds, all of these elements in this column right here will have a 1 negative charge. All of these in this column will have a 2 negative charge. All of these in this column have a 3 negative charge. If you're putting together an ionic compound and the anion is something in one of these 3 columns, it's -1, -2, and -3. Okay? Over here, all of these, if you're putting together some kind of ionic compound, all of these are going to be a 1 plus. Yes.
Do you have videos or something?
Oh, I thought he needed. Yeah, I've got it right here.
Okay.
Oh.
They were just really
Stressing out?
Really confused.
I've got it right here.
Okay. So just as long as you had it, I wanted to make sure.
Do you want me to give it to him now?
No.
That's fine.
He just was having a little connection.
I got it. There you go. I got him all taken care of.
Okay.
All right. So this is +1, this is +2, and this column will be +3 actually. Okay? And the transition metals here are kind of strange sometimes, so we don't really worry about it too much. These happen to be positive 3, as well as these right here. But then after that, you start getting all this stuff that's kind of crazy numbers that, unless you know a lot more about atomic structure, that may not make a lot of sense to you. Okay? But that is a good thing to know. Positive 1, positive 2, positive 3, positive 3, negative 3, negative 2, negative 1. Whoop, I went off the screen there. Negative 3, negative 2, negative 1. Okay? That's a good thing to know. All right. So then fluorine is in that 7th column where everything has what kind of charge? Negative 1. So we're going to put a capital F with a negative 1 charge on it. We need to get these balanced. I have a 6 positive charge particle here. I have a 1 negative charge particle here. So I need enough of these negative particles to balance out this 6 plus charge on this positive particle. So how many of these do I need? 6 of them. And when I put the formula together, then the coefficient, when I have 2 separate ions, the coefficient here becomes a subscript in the bonded form of this formula. Okay? And this will have the same point scheme as before. Oops, wrong marker. 1 point, 1 point, and 1 point for balancing it properly. Okay? So this is going to be worth 12 points. This section is 12 points here. So 12 and 16 comes out to be 28 points total. Total for the whole homework, 28 points. Okay?